Hello everyone and welcome back to another Python expert tutorial series. What we're going to be doing in this video is covering metaclasses, a fairly complex but very interesting topic in Python. So we're going to start from the very beginning and start understanding how classes are actually created, instantiated, the way they work on a lower level in Python, and then from there we're going to move into what metaclasses are, how they actually work, and why we would even want to use them. Now, I'm just going to preface this video by saying metaclasses are an extremely complex thing. I'm only going to be showing kind of the basic implementation of metaclasses here. If you really do want to use these, you're going to have to look up the documentation and implementation details on your own. And there's very few instances in which you need a metaclass. A lot of what I'm about to show you can be accomplished in other ways. And typically, you're going to want to use another way other than a metaclass just because these are seen as very complicated and almost sometimes bad practice, depending on what you're trying to do. So these should really only be used by experts. I mean, I'm showing them to you guys so you can get an intuition on how they work. And if you see one, you'll understand what it does. But you shouldn't really be putting these into your own code and using them unless you absolutely need to. So before we get into the content, again, a quick thank you to Kite for sponsoring this video series. They have a download link in the description down below. You can download them for free. They are essentially a very good Python autocomplete. So you can see if I start typing some things like this, we get a Kite completion thing popping up. And anyways, that's what they are. They're free. You can download that from the link in the description. All right, so let's go ahead and get started. Now, the first thing that I want to do is really discuss how classes work and what classes are. So we saw in the previous example, in I believe 2 videos ago, I did something crazy like this, right? And I made a class and I defined it inside of a function. And then in that function, I actually just returned the class itself. And this is totally fine. This is valid syntax. You can see I just ran the code down here. We don't get any errors. That's fine. The reason we can do something like this in Python and not in other languages is because in Python, classes are actually objects. Now, the property of an object essentially means that we can interact with it at runtime. We can pass it around through parameters, through variables. We can store it, we can save it, we can modify it, we can interact, right? That's what an object is. Now, a lot of people are going to say, well, how is a class an object? I thought a class created objects for us. Well, that's very true. A class does create objects for us, but that doesn't mean that it's not an object itself. And if a class is an object, if you believe what I'm saying, and I'll prove it to you in a second, then that means we must have had some higher level class that created that object for us, right? Just like if I make an instance of hi and I do something like that, that means we must have this class hi such that we can make an object, and have the instance for it. So what we're going to be getting into here with metaclasses is the basic idea is a class defines the rules for an object, right? It defines the attributes, the parameters, the methods, the things that are allowed, the operations that can be performed. That's what a class does for an object. What a metaclass does is define the rules for a class. So when you create a class, you will use the metaclass to create it. This happens automatically. You don't need to type anything specifically, but we're going to hook into it later and see how it really operates. And that metaclass defines how this class is created. And that's the basic concept here. So I'm going to make another class, and I know this is confusing, but as we go through here, you're going to start to slowly understand with these examples. And all I'm going to do is just print an instance of this class. So let's look at it. We can see this tells us it's an object, main test object at some gibberish location. So now let's print above this just the class itself. Okay, look at that. Class main.test. Now, the reason we're able to do this, again, is because this is an object. So I know this doesn't explicitly say object, but this class is an object. Now, I want to look at something else. So we know we have this method in Python called type. And I can look at the type of a class or an instance or an object, and I can see what it is. So let's look at it. When we do the type of test, we get that it is in class main. If I were to print, say, the type of an integer, right, like the type of 2, let's have a look. That's class int, right? And we could print, the type of whatever we want. We could print the type of a function. So we say define func like that, and then we'll just say pass in there, and we do func. What's that? That's class function, right? So that exists in a function. So this is an object. This function's an object. Everything in Python is an object, and that means they have a type and they were created somehow. So what is the type of a class? Well, let's look at it. So we'll delete all this, and then we'll just print the type of, and I somehow hit insert accidentally there, of test. So what do you think this type is? Is it of type test? Is this class of that type? No, it is of class type. Now I know this seems ridiculous. This means nothing to you right now. We're going to dive into what this is, but essentially this is what we would refer to as the metaclass. So this type is what essentially defines the rules and creates this class for us. When we type this class syntax, we will call a type constructor using the different things in our class to make this class object that we can then use to make objects and use to interact with in the program. So what is type? How does this type thing work? Well, if I told you that this class, all this is doing, this syntax is just calling this type class, then we should explicitly be able to create our own objects without typing out the syntax like this. We should just be able to use the type class itself, which is true in what I'm about to show you. So I've just created a class, test, it has pass, it has nothing in it, right? Now I'm going to show you how we can make this without actually having to type this kind of syntax and writing out class. In fact, and this seems ridiculous, I agree, Python should have done a better job when they defined this, but I believe it's something to do with just backwards compatibility. We can make a class by doing this, and just watch and then we'll talk about exactly how it operates. So this line of code is completely equivalent to this. These two things are completely equivalent. There's absolutely nothing different about them, and I can use test here the same way I can use test here. Just like I can create an instance of test, I can create an instance of this other test. So let's do it. Let's prove it to you. So if I print test and make an instance, boom, main test object. Works totally fine. No issues with that. What else can I do? I can print the class, and again, same thing. We have that object, totally fine. That's because this function here essentially creates the class for us using these different arguments. A name, this is the internal representation of the class. Any bases, which means anything that we inherit from, so like a superclass or a parent class, and then any attributes. So let me start showing you what I mean, and then hopefully this should make some more sense. So I'm going to set an attribute of 5. I'm going to say t equals test, make an instance, and just print that attribute, I can go like this, of t.x. So just like this works on a regular class, we can do that, we get our value 5. Now, just like in regular classes as well, I can define attributes outside of the class. So you say something like t.wy, why not? Set that equal to, let's just say, hello. Want to print wy? Sure, let's go for it. T.wy, 1 second, guys. Oh, t is not defined, so that needs to go above. So I can explain metaclasses, but apparently cannot just create regular classes. Okay, so that's totally fine, that works. We have t equals test and then t.wy equals hello. We can print that attribute, that's totally fine. So that's how we can create classes using type. Now, what about methods? What about sub? I'm going to show you all of that. So we'll do that now. And then we'll get into actually metaclasses and how this is even useful to us. So what I'm going to do is make another class. I'm just going to call this class foo. Let's just make a method in here just called print. Actually, not print. Let's do like show. And then all we'll do in here is take one attribute. We'll say self and just print hi. Why not? Right? Just do that. So if I want to now have an inheritance, what I can do is simply type the name of the class, a comma, just to make sure this registers as a tuple here. And now test will inherit from foo, which means that if I want to use the method show, I can do that and I can run that like that and we get that. Now I shouldn't have printed that out because I forgot that wasn't a return value, but you can see we get hi. That works totally fine. This is how you do this, right? Now, what if I want to add methods, right? So to add a method is a little bit different, but essentially what you're going to do is just define a function that will be the method signature. So in this case, let's say, add attribute, put self like that. And then here we just say self.z equals 9. Why not, right? We'll do that. And then in here, we'll define our attribute. So we'll say add underscore attribute, colon, guess what we're going to do? Add attribute, no brackets. Now, make our instance. Let's call t.addAttribute, and then let's print t.z, like that. And let's look at this, and there we go. We get the value 9. That works fine. So this is how we use type. This is how we create a class, and this is very important to understand as we get into the next part of the tutorial here, because if you can understand how we use this to create our own classes, then you're going to understand the next part and why, when we have a syntax like this, all this really does is pass that information to another class called type that creates the class for us and returns an object that represents that class. Now, I know this was a lot. I hope you guys understand at this point. Now we're actually going to get into metaclasses. This was just the underlying information we need to understand. All right, so welcome to the next part of the tutorial. What we're going to be doing now is actually getting into metaclasses and showing how they work. So again, the basic principle here is to remember that a metaclass is above the classes you're creating yourself. So if you create something like class dog, right, and you do that, what's actually happening is all this information that you type out, the syntax, gets passed to some meta class, the thing above it, that actually takes that and returns to you an object that represents that class. And that's the whole point here. So what we're going to do is actually make our own meta classes. So rather than using that built-in type class, and you could see on all of our objects when we looked at the type of them, they were of type. We're simply going to make our own meta class that inherits from type, so does a very similar thing, but we're going to change slightly how objects are constructed so you can really understand how this works. Now, you might get lost a little bit at the beginning when I start typing some of this stuff out, but hopefully you should start to follow along as we go through and explain how all of this works. So let's get started. I'm going to start just by creating a meta class. I'm going to call this meta. Now, whenever you make a meta class, what you have to do is make it inherit from type. Not necessarily, but for our purposes, that's what we're going to say. It has to inherit from type to make a meta class. The reason for that is because type does some other things when it's creating an object, right? And if you don't inherit from this, well, your class is just going to be not a meta class now because it's going to be using type to create this kind of class, if that makes any sense whatsoever, but hopefully that does. What we're going to do now is I'm actually going to define a new method like this. And for those of you that don't know what new does as a dunder method or a magic method like we talked about before, essentially this is called before the init method. So this is the first thing that is always called when an object is created or instantiated or whatever you want to call it. This is always called first. So what you can actually do here is hook into this and modify the way an object is constructed by changing what happens in this new method. Whereas the init, all the init is doing is after this new method gets called and the object is constructed, what it does is it initializes it. It changes the values, it takes some parameters in, like that's what it does, right? Whereas new is just called beforehand to modify the construction of the object. Okay, so what I'm going to do in here is I'm going to take self, I'm going to take class name, and remember, this is what's going to be called whenever we create another class that uses this as a meta class. We're going to say class name, we're going to say bases, and bases is what we put, remember in that type argument when we want to do inheritance, we have the name, we had the bases, and we had the attributes. And guess what this last one's going to be? It's going to be attributes. So essentially, we're saying, okay, when we create this new method, the construction of a class, which happens in this meta class, needs to contain the class name, the bases, and the attributes, so that way we can look at them, we can do something with them, and we can return to you a class that has those pieces of information, right, as an object. So what I'm going to do now is simply just return the type of, in this case, it's going to be class underscore name, bases, and attrs. Now this is very simple. We're not really going to do anything other than this, but I'm also just going to print out the attributes so you can see what they look like, okay? Now what I'm going to do is I'm going to make another class. I'm going to call it dog. This is going to have a meta class that's equal to meta, like that. And then in here, all we'll do is just say x equals 5, y equals 8, just so we can look at some things when we print these attributes out. And then we'll create an instance of dog. So we'll say d equals dog like that and run the code. All right, so look at this. What has happened? Well, actually, I'm even going to get rid of this and just show you that even if I don't create an instance, this still runs, right? You can see no instances, this is still running. The reason for this is because the default meta class of dog is type, right? That's what it runs, and that's how the class is created. What we've done is we've overridden that. We've changed it to our own meta class, and essentially we've added our own little piece here that just prints out the attributes and then returns to us an object. And remember, this is an equivalent way of creating this class by just literally typing this line, and this is what happens. This is what we get. So we can see that we have the attribute module is equal to main, the qual name dog, so that's the name of this class, right? And then we have our attributes, so x5, y8, that we've defined down below. Now, what if we define a method called hello, and we print, say, hi inside of here? Well, then you can see we have dog.hello at some memory location. That's mapped to by hello, and that's a function. So that's how this works. Now, knowing this information, metaclasses can be very powerful because, for example, let's see, like I can hook into the construction of this class and I can modify the construction of it if I want. Now, this is something you would never do. What I'm going to do is actually change all of the attributes that I have here to be, uppercase. So I'm going to change this X to be a capital X, this Y to be a capital Y, and this function hello to be capital hello. So all capitals. I won't bother changing, I can't change these underscore methods, but I'll show you how we do this. Okay, so let's start programming this. So what I'm going to do is I'm going to make a blank dictionary. I'm just going to call it A, because notice down here that all of my attributes are actually in a dictionary, right? So what I'm going to do is modify this attributes dictionary based on the attributes that were passed in and make them all capital, assuming that they don't start with 2 underscores. So what I'm going to do is say for item in attrs.items, and I'm not sure if the syntax is 100% correct, so there might be a mistake here. We're going to say if item dot starts with, and in this case, it's going to be underscore underscore. Then what we'll do is simply just add it back into the dictionary. So actually, yeah, we'll just add it back into the dictionary. So we'll say A, in this case, item equals attr's, and then item, like that. So essentially, since this is a dictionary, the way this is going to work, right, is we're just assigning this item to this new dictionary. It's just literally the same thing, right? Okay, otherwise, so if it doesn't start with a double underscore, we need to change it to be uppercase. So we're going to say A, and in this case, item.upper, like that, equals attr's item. Then we'll change the attributes here to be A, which will be our modified attributes. And that means when we return this dog class, this should work, assuming I haven't made a mistake, which is likely, but let's look at it. And let's see what I got wrong. All right, so I guess I've forgotten the fact that when we do something like this, I need to actually loop through with name value rather than just item. So name will be the attribute name. Value, obviously the value mapped with it, just means we're gonna have to change a few things here. So we'll say name. So if I have to do that, we can change that to val. We can say name, and that's, yeah, so name here. This will be val, like that. And I think we should be good on that front. Let's run that. And let's have a look at this error. Name val is not defined. Of course, I've made it value. Let's run, and there we go. We get good. Okay, so I haven't proved to you really what happened, but let's just step through this code because I did make a few errors, so it might be confusing. So we started by printing the attributes. We then made a blank list, a blank dictionary, sorry, that's going to represent our new attributes. And then we've looped through all of the attributes. So we just do dot items to get the name and the value. And we said if the name starts with a double underscore, just add the proper value back in. Otherwise, what we'll do is add the uppercase attribute with that corresponding value. So we've changed them to uppercase essentially. So let's actually print the values down here. So the new values, just have a look at the difference. And you can see if we scroll up here that notice hello has been changed to capital hello, X to capital X, and Y to capital Y. So now let's do another proof just to make sure that all of you believe me that this is okay to do. And let's go down here and say d equals dog, create an instance, and let's try to see what d.x is. So just print d.x. Well, what is the error? Let's look at this here. Dog object has no attribute x. What? But we defined x up here. That's because we've changed it to be a capital X. And notice that when I do that, that's totally fine. And same goes with hello. I can't access that, but when we change that to capital hello, we're totally fine because, again, we've modified the construction of the object. All right, so now that we kind of understand how metaclasses work, we've seen that we can hook into them, we can change the way that objects are created, we can enforce certain constraints, I can change all of the attributes to be capital, I can do whatever I want, right? I could change the bases, I could remove an inheritance if I didn't want that to be allowed. Essentially, this is why they call it magic, because with this kind of hook into the creation of classes, you can really enforce quite a bit of constraints on how classes are created. So for example, if you want every single class in a specific module to never be allowed to use a certain attribute or to only have, or to have that attribute, you could set metaclasses for those, or for that actual specific module, which I'm not going to talk about now. And then when that module is run, it will check the metaclass, right? It will go through the metaclass. That's how we'll create the classes itself and make sure that all of these classes kind of conform to that structure that you've defined. Now, this is specifically nice for when you're writing kind of library code and you want your user code to be very specific. Let's say they're inheriting from a specific type. You could check if they're inheriting from, whatever type it is that you want. If they do inherit from that type, you can enforce the fact that they have a specific function or specific method in that class that's needed to make that work. So that's some of the things that you can do with metaclasses. Again, they're very complicated. There's not really like a need to use them, so you don't necessarily need to implement them into your program, but sometimes they're cool, and understanding how this class construction works to me is even a better benefit of using the metaclass itself. So I believe there was one last thing that I wanted to cover here, although it's not coming to me at the top of my head. I mean, I think that's pretty much it. I don't know what more I can show you guys. You can have metaclasses that inherit other metaclasses. You can do very, very complex things with that. But I think, honestly, for now, we're going to wrap the video up at this. I hope you guys enjoyed. I hope you understand now how classes are created, how metaclasses work, and what the heck they even are. And I hope that you understand that you don't need to use this. And the point of this video is to introduce you to the concept and make you more familiar with the way that classes and objects actually work in Python. So anyways, that has been it. I hope you enjoyed. Make sure you leave a like if you did, subscribe to the channel, and I will see you in another expert Python tutorial.